Right on schedule, Java 22 is available on the 19th of March. Let's discuss what this new version brings.
Welcome to the Foojay Podcast, all your news about OpenJDK.
Last September we got Java 21, a long-term support version with 8 new big features and 7 Incubator or preview features. Does Java 22 also bring that much innovation, or is it just a bug fix release? And what needs to be done to get such a release published on time? Let's find out with these guests.
Hi, I'm Simon Ritter. I'm the Deputy CTO at Azul.
Hi, I'm Loïc Mathieu. I'm a software engineer at Kestra.
Thank you both. Welcome in this podcast. I'm Frank Delporte, creator of the Foojay Podcast. Before we dive into the details, are you excited about Java 22?
Yeah, I'm not sure excited would be the right word, but I think it's an interesting release which has a number of new features which will be of benefit to developers. But I guess, obviously, because it's not a long-term support release, adoption is going to be a little bit lower than like JDK 21.
Yes, at first I was thinking that Java 22 will be a stabilization release, but in fact there is a lot of interesting new functionality in it. So yes, I think it's very interesting release. But as Simon said, usually the releases that are not long-term support are less used in the community. So we will see.
Now, the releases are very punctual. They're very on schedule, more punctual than the Belgian trains, I would say. How this is achieved? Who is driving this? Is this the community? How does this project keeps on track and keeps following the schedule of the 6-month releases?
Well, this is something that changed with JDK 9, because prior to JDK 9, we had a feature-based release schedule. And the idea was that the developers of the OpenJDK would come up with a list of features that they wanted to add to the next version of Java. And then they would work their way through that. And only when all those features were ready would they make a release. And if you look at pre-JDK 9, what you'll find is that we had anywhere between a little over 2 years and almost over 4 years between releases. So the JDK 6 to JDK 7 was over 4 years between releases. So they had to delay potentially the release because a feature wasn't quite ready. What they did from JDK 9 was move from that feature-based release schedule to a time-based release schedule. So it will come out on specific date in March and September, and only what is ready will be included. And if the thing isn't quite ready, rather than delaying the release, they delay the feature to the next release. And again, because it's only 6 months, it doesn't really make that much of a difference. So it's a much more controlled way of doing things.
Mm-hmm. So I guess there's a bit more pressure when we reach a long-term support version, and some features should really be included than now, for instance, with the 22 release.
Well, no. You see, that's one of the things that there's a bit of a misunderstanding. And certainly if you ask the OpenJDK developers and people from Oracle, they'll be very clear about this, which is that although the LTS releases are considered, the ones which have extended maintenance and extended support, all of the other versions are also quite available, quite useful in terms of deployment. There's no reason why you can't use JDK 22 in production. It's not like a sort of intermediate beta release or anything like that. It's all about being able to use those releases if you want to in production, but obviously the LTS ones are the ones that typically people will rely on. So we do need to be careful about thinking about features going into an LTS release versus a non-LTS release.
So people can see on openjdk.org what features are being developed, what projects are ongoing. I subscribe to the mailing list of JDK Updates Dev, and I must say there's a lot of discussion going on there. What should be ready, what should be included, what needs to be done. How should people follow evolutions in OpenJDK? Should they be on the Jira of the project, or should they be on the mailing list, or just keep an eye on OpenJDK, or follow on Foojay or this podcast? What is the best way to know what's happening there?
Personally, I use multiple source of updates around OpenJDK. I follow some mailing list, not the one you talk about, but the OpenJDK mailing list are really high number of messages, so it's not very easy to follow them. But I really appreciate the Umber mailing list because the Umber project is really shaping the future of Java. It's very interesting to follow the discussion here. I try to follow the core dev mailing list. This is the main mailing list about development inside the OpenJDK, but it's really there is really too many messages. For me, the best way to follow OpenJDK, if you are not actively working on OpenJDK, but want to know what's going on the Java language, is to follow some people working on it, because they usually tweet if you follow them on Twitter or on other social media, to listen to some podcasts. For example, Foojay Podcast, but in France we have other podcasts, and also inside Java is very interesting. Unfortunately, I don't know why they didn't have a Twitter account where they post the messages they add in their blog in their website. I found it more easier to follow people that talks about OpenJDK than directly follow a mailing list.
Mm-hmm. Yeah, I agree. I mean, very much the Amber mailing list is great because that obviously tracks the new features being developed and proposed for the language specifically. I also follow the JDK Dev and the JDK Discuss aliases because they're not too high traffic. I mean, I agree that some of the aliases can be very high traffic, and trying to work your way through all of the discussions is like a full-time job. I think the other thing that I would always come back to is that if you go to the OpenJDK website, you'll find that for each version of Java, there's a page for the project, and that will give you details about the schedule, as in when the when the lockdown is happening, when the release is coming out, and so on. But it also lists all the JEPs which are proposed to include on that, so you've got a clear list of the things that are actually going to be in that release, and that will be added to over the 6 months of development. So that's always a good way of doing that. And obviously JEPs are the way that we propose and include new features into Java at the moment.
Mm-hmm. And that brings us perfectly back to Java 22 release, because I will add to the show notes a link to project JDK 22, which is the one being released this week when we publish this podcast. And I see there are 4 JEPs as new features, and the 8 JEPs even are preview and incubator features. How should we handle these in this podcast? So I think the 4 which are really new features are the important ones. So it's a region pinning for the garbage collector, for function and memory API, unnamed variables and patterns, and launch multi-file source code programs. Anything you want to say about one of these or all of them?
Well, I could talk about all of them.
Perfect. Go ahead.
Yeah, I mean, region pinning for G1 is a fairly sort of small thing. It's designed to reduce latency associated with the garbage collector. And when I say it's a fairly small thing, it more relates to when you're using JNI, because JNI is obviously for interacting with systems outside of the JVM. And that can have an impact on the way that the garbage collector works, because of the fact that some pieces of memory can be shared through JNI, and G1 has to make a decision about how to treat that, because you can't relocate objects in the heap whilst JNI thinks that they are in a particular place, because then you've got a disturbance between the two. So it's a fairly small thing. Because if you're not using JNI, it won't have any impact on your code. So that's region pinning for G1.
It's always good to know that the OpenJDK team continue to improve the garbage collector, because for a developer point of view, having a garbage collector is really great, because you just don't care about your allocations. So that's the only thing I love is this kind of change that it allows me as a developer to not take care of memory because the garbage collectors keep improving over time, and not only the last cutting edge garbage collector, because there is a lot of garbage collectors inside the DVM, but also all the garbage collector, if we can say that G1 it's starting to get a little old.
By the way, I will also add to the show notes a link to a blog post I wrote about all the different garbage collectors, because indeed there are a lot of them, and you're definitely right that they all are further maintained and have specific use cases also.
Mm-hmm. Some better than others.
Some better than others, and some companies even have others, like Azul has.
Yes, C4.
So yeah, it's a long list of garbage collectors, totally right. Okay, the next one is Foreign Function and Memory API, JEP 454. What can you tell about that one?
This one is interesting because we usually said that to attain the last bit of performance of a program, better to write it in C. And there is a lot of languages that basically are using C libraries to offer good performance. Java, on the contrary, have good performance thanks to JIT and garbage collector that are very efficient. But there is still some time that you want to access foreign library. There is still usage in native libraries. And this JEP is all about providing a better interconnection with foreign languages. And it's good that Java can still be on the edge of interconnection with foreign language. For the foreign memory, it's just being able to easily access foreign memory. It's linked to the foreign library also. So it's these two new API. It's great that there are no finalized. I think this is what's more important.
Yeah, because the whole foreign function and memory API is part of a larger project called Panama. And Panama is all about replacing JNI. So it kind of comes back to what we were talking about on the G1 side of things. And as we said, it's the idea of being able to interact with foreign libraries and foreign memory. So the sort of two distinct things here. First is if we look at the memory side of things, that's because we need some replacement for things like Sunmisk Unsafe, some of the functionality that gets used in there, so that we can still get access to native memory without having to go through the undocumented, unsupported API of Unsafe. I mean, there are other things that Unsafe does as well, but there's some of that functionality that's being replicated here in a standard API. The other thing is the foreign function API, which is obviously to enable you to access libraries which are written in other languages. This is quite an interesting thing, because I remember that as replacement for JNI, you think, well, why do we need to replace JNI? But if you've ever used JNI, you'll know why we need a replacement, because it's a difficult to use sort of interface. And I remember when I worked at Sun, using JNI and then thinking, oh, this is really hard work. I've got to generate my header files. I've got to generate my stubs. I've got to make sure I get my library linked in the right way and all of that sort of thing. And I remember talking to one of the developers of JNI at the time and saying, this is really quite hard to use. And he said, yes, we designed it that way. It was like, what? It was like to discourage people from using it. So I think the idea of having a more formal, easier way of doing things is very interesting. One sort of small note on this that I will say was that one of the most useful tools in this is a thing called JExtract. And what that allows you to do is to sort of generate the necessary interfaces and so on for an external library in a very simple and straightforward way. But interestingly, it's not been included in the JDK. So you have to do it as a separate tool. And I did kind of question this with, I think it was Brian Gertz I asked about this. And he said that actually the problem is it's quite big. And when we look at the size of the JDK, they don't want to add sort of bloat to the JDK And that makes perfect sense to me because there aren't going to be a lot of people that use JExtract. So they're keeping it as an external tool rather than bundling it with the JDK. So it's just interesting in that kind of respect. So yeah, that's kind of the foreign function and memory API. It used to be two separate things, and then they've kind of brought it together in one.
Am I correct that I've seen a lot of talk about this related to AI, machine learning, LangChain4j, that they want to make use of these improvements?
Yes, absolutely. I mean, that's one of the main sort of uses I would expect to see of this, is that linking to those machine learning, LLM type libraries is going to be a big thing for Panama. Yes.
There is also one thing that brings this this new JEP is that you can now directly access the standard library from Java. There is no need to use JExtract, for example, because it's already integrated into the JDK. So it brings new capability. It's cool. For example, if you want to have timestamp in microsecond, you can have it easily, which is not possible with plain Java.
Okay. The next JEP is, I think, 456, more about developer improvements and making code more readable, and that's unnamed variables and patterns. I think we're going to see a lot of underscores, correct?
Yes. So it's add underscore forbidden keyword for some releases now, and it allows using underscore as a name in use the variables and pattern. In case of pattern matching, for example, in a switch.
Mm-hmm. Or even in variable names in a method, I think. If you call a method, and you don't need that variable, you can still have the underscore there, something like that.
I'm a little disappointed that you can choose underscore when you override a method, for example, to say that this parameter is not used in an overridden method, which is something that is quite usual, maybe for next release.
Yes, because this is one of those getting little interesting sort of pieces of information, because prior to JDK 9, you could use a single underscore as a variable name. If you really wanted to, you could. From JDK 9, it became a reserved word, a single underscore. So you couldn't use it as a variable name anymore. However, the good news is that if you want to use 2 or more underscores, that will still work as a variable name. So you can replace your single underscore with a double underscore or more. And the reason they made a single underscore into a reserved word is because they wanted to use it in the future. Initially, the idea behind this was to actually for lambda expressions, where if you had a lambda expression and the number of parameters that you had there, you didn't need all of the parameters on the right-hand side of the arrow operator, then you could effectively say, I don't care about this, but I need to indicate that there is a variable there. And I'll use an underscore to match the signature of the method, and then not bother using it on the other side. So they haven't actually implemented that yet. But what they have done is allow you to use that in the record patterns, so the deconstruction pattern, and various other places as well. But take the record pattern as an example. If you've got a record pattern, you want to do deconstruction on that. I've got a good example in one of the presentations I've done where you can actually have a number of records sort of embedded in each other. And when you get into the situation where you're taking one particular variable out of an embedded record, then it becomes very complicated because you've got all these variables involved. And even if you switch to using var to hide the types of those variables, it still gets quite unwieldy. So by using a single underscore, you don't have to have any kind of type information, any variable information, and it does make it much more clear and readable as to what it is you actually want from that deconstruction in the body of what where you're going to use it. And you can use it in the pattern matching for switch as well. So if you've got a variable that you don't need on the other side of the switch because you're just doing a print statement or something, you can use it in that kind of place as well.
Mm-hmm. You just mentioned very briefly, they reserved it in Java 9 because they thought of using it in a different way later. So now we are on 22, and now it becomes... So that really shows that there is a big master plan behind Java. Am I correct? Or was it just, one day we will use it, or were they really convinced we will need this later if we want to do this?
Well, it was, like, as I say, the initial reason for making it a reserved word in JDK 9 was because they wanted to use it in Lambda expressions. And so Lambda expressions came in JDK 8. There was a piece of functionality that they created, which was called Lambda leftovers. And there were a number of different pieces that they wanted to include to sort of move lambdas forward a little bit and take off some of the rough edges again, sort of Project Amber style. Interestingly, this was one of the ones that they had planned for in that, but they've never actually implemented it. And so when they came to do the patterns with this idea of unused variables in patterns, it was very easy because they'd already done the work back in JDK 9 to make this available, so they could do it that way.
In fact, and this is what is interesting when you read the Amber Dev mailing list, is that there is a lot of functionality they want to add to the Java language, but they need to prioritize them. And using underscore as unnamed variables, they think about it since multiple years, but they start working on it only recently because there is more. There is some other features that appears to be more urgent to do.
Then we have the fourth new feature, which is JEP 45H, launch multi-file source code programs. So I know since I think Java 11, you can just execute a file .java, and actually Java compiles it and then runs it, executes it. But now you can do that with multi-files. What is the idea behind this?
This is part of a bigger sort of project, which is to make Java more approachable. So for people who haven't written Java before, the amount of what they describe as ceremony is very heavily evolved. There's a lot of it. And so this is one of the things that they did, as you said, back in JDK 11. They introduced this idea that rather than having to create a Java file which had your source code in it and then run Javac to compile that file and then run Java with the JVM to actually execute that file, we'll make it a little bit simpler and take out one of those steps so that you can simply write your Java in a source code file and then execute that, which allows the underlying JDK to say, right, we'll compile that and then run it. So it's really just taking out a small step. And in fact, when we come back a little bit later on, we'll talk about one of the sort of new features, which is still in preview, which is JEP 463 about implicitly declared classes and instance main methods, which is also related to this. But the idea behind JEP 458, which is launch multi-file source code programs, is extending that idea of taking a single source code, which allows you to then have the compiler run automatically and then execute, and do that for multiple files. It was a limitation that was on the initial way of doing this, is that you could only do it for one file. You could add things to your class path as compiled code, but now what you can do is you can have several files which contain different classes, and you can do it that way, and then you can still run that and have the compiler do that.
I do love to use JBang for projects like this, where you run something very briefly. I think the main difference is that you still cannot define dependencies with just Java, and you can do that with JBang.
There are still limitations on this. As I say, the big thing here is it's trying to make it easier for people who are starting out with the language. So it's not designed for complex situations. As you say, I mean, JBang is a good example of how you can do things for prototyping. JShell is another approach for making life simpler. If you just want to test a piece of code in isolation, I always do it in JShell just to make my life easier. But yeah.
Yeah, and what's interesting is that it compiles in memory what's needed, so you can have a bunch of Java files, and it will not compile everything. It will just compile what's needed. And I think the idea also is to say you can start simple and start to complexify your program without needing to add too much complication. It's just to be able to evolve your program step by step. Continue to don't run a compilation step if you don't need it, because Java doesn't have a built-in dependency system, like you said, but doesn't have neither a built-in build system. You need to call Java before launching. There is nothing that do it automatically for you. So just really being able to evolve your program step by step.
Okay. So this concludes all the new features. There are 4 new. Of course, there are also bug fixes, I guess, and other small improvements which are outside of the JEPs. But we also have 8 preview and incubator features. So for people who are new to this, so these are included in the release, but you need to use an extra flag to use them when you compile your code or execute your application. You mentioned one, JEP 463, which is removing some of the ceremony around the main method and stuff like that. Which are the important other ones that we should know of? All of them?
Stream Gatherer, for sure. Stream Gatherers is really the biggest new features of this Java version. It allows to add intermediary steps in stream processing in a stream pipeline. Today, the Stream API that was added in Java 8 has a built-in step. You use map, you use filter, and there is one terminal operation, for example, collect or forage. And for the terminal operation, you can enhance the Stream API with your own terminal operation, because collect allows you to create multiple collectors. But if you want to enhance the Stream API with intermediate operation, you cannot. And this is what Stream Gatherers bring us, is a way to enhance the Stream API with custom intermediate operation. What is interesting is that when they add the Stream Gatherer capability, they also add new intermediate operation. So this allows so we know as fault, map conference, scan, window, fixed window, sliding intermediate operation that are new in this release. So they brings both capability for us as developers to add new intermediate operation, and they brings new intermediate operation into the GTK.
Yeah, I absolutely agree. Stream Gatherers is a very interesting new feature. As you say, it's about enhancing the ability to sort of add more intermediate operations and define your own ones. So yes, it does provide us with a lot more sort of possibility, because the thing with the Stream API is that obviously we've got a rich set of intermediate operations, but people are always coming up with new ideas for things that they could include. And if we added all of those to the standard API, it would become completely unwieldy. So, and you'd find that a lot of those would be very kind of niche and only apply in a very small number of situations. So by making it flexible and that you can define your own, it really adds that power, so that you just say, okay, well, if I don't have exactly what I need in terms of those intermediate operations, I can create my own, use it for my code, and then, yeah, sure, if I want to make it available, I can, publish it as a library. But most of the time, you just go, right, I do what I need to do in my code, and I get exactly what I need out of that. So it's a very good addition to the Streams API.
So it's making the streams even better. And I have to say that is the most important change in Java for me when I do development, to produce clean code, readable code. I think streams are crucial in the Java that we know today.
It's fascinating, isn't it? Because it's the whole idea of adding a functional style of programming to an object-oriented language. And I have to say, I'm always a very big fan of people like Brian Gertz and Stuart Marks and the people who kind of worked on this. I have to say, I really think they've done a fantastic job of adding that functional style of programming to the language without making it overly difficult, without breaking things, without kind of changing things in a very strange and unfamiliar way. So they've done a fantastic job of adding that. And as you say, loads of people, that really kind of made JDK 8 very appealing as a new platform because of the inclusion of streams and Lambda expressions. So we could do all of these things. And this is just making it that little bit better, more flexible.
Another one, a preview feature, is JEP 447, statements before super. That's really, I think, for a lot of developers, a big change, that you can put something before super. Why is this needed?
It's not needed. It's, again, a new capacity. So before, you cannot do anything in a constructor before calling the superconstructor. So this leads sometimes to situation where you call the superconstructor, then you, for example, do some check on the parameter of your constructor, and for example, throw an exception because you validate the parameter and validation didn't pass. In this case, you could have done potentially unnecessary work in the superconstructor. But also, this sometimes prevent reusing a superconstructor because there is something that you need to do before calling it, and it's not possible. So this allow more flexible constructor implementation.
Yes, it's one of those things where you think to yourself, well, okay, Java is going to be 30 years old next year. So we're actually coming up to 29 years of Java. And we haven't had the capability of putting code before super calls up until now. So it's not something that has been absolutely desperate for the language. But it is something which is, there are plenty of cases where it would just be really nice if you could do that. You need to read the JEP carefully because there are quite a few restrictions on what you can and can't do in terms of using that. So you can't just simply add whatever code you want before the call to the superconstructor. So you do have to look carefully at what you're doing so that you're not stepping outside the rules, because there's a lot of the way that the JVM builds objects and the fact that you've got superclasses that need to be populated in terms of instance fields and so on, you do need to be careful about how that works. But yes, for certain situations, this is going to make life, again, it's just taking those rough edges off the language, which is what Project Amber is all about. And that's just one of those things where they've included this feature and said, yeah, we know that there are situations where people would like to be able to do this. We will add that feature.
Okay.
But again, I'm just going to make one more point about that, which is, again, they've done it in a really good way because it's backwardly compatible. It doesn't break any existing code. Everything still works in exactly the same way.
Which is key factor for Java.
Mm-hmm.
Yes, and during the development of this JEP, they also add new warning in the compiler to detect misusage of constructors, and it's very interesting also because it will catch up more implementation issue especially when you escape inside the constructor, the instance being constructed.
Simon, you're my returning guest for this podcast about Java releases. If I remember correctly, last time, 21, you said the Vector API could be a release in the next one, but I see it's in the list of the previews. No, it's a 7th Incubator.
Yes.
Right?
And I got to say that this is now the record holder in terms of how many times it's been through Incubator and previews. Because what is that? Let me just check. Vector, it is an Incubator, yes, right.
It's an Incubator.
Subtle distinction between an Incubator and a preview feature. So yes, it's still an Incubator, and they're still working through things, but there wasn't really that many changes. There's only one minor change that they made between what was in JDK 22 and JDK 21 and JDK 22, which is where you're using a memory segment, the backing store that you have behind that. In the previous releases, it was had to be an array of bytes, and now you can use any primitive that you want in terms of that backing store. So it's a fairly sort of I'd say it's a little bit esoteric in terms of the change, but it will be useful for certain people. The Vector API is one of those things which it's an interesting approach. What they're trying to do is help people to get better performance for numerically intensive code. And it allows you to tap into the ability to use the single instruction, multiple data features that are common across any modern processor. So your vector, which is a very wide register, you can then populate that with a number of elements from an array, and you can have the same operation applied to all of those elements in a single clock cycle, which is very, very good. The thing is that when you look at this in a bit of detail, what you'll find is that there are you're not going to use this in every situation. And the reason I say that is because the compiler, the JIT compiler, already knows about single instruction, multiple data vector operations. So it will apply vector operations where it can. And there's lots of situations where it does that. If you're using a simple loop and you start to do things in that where you've got processing an array and you're doing the same operation on that, what you'll find in terms of the code that's generated by the JIT compiler is it will use those vector operations. So you won't get any benefit from writing explicit code using the vector API to do that. The situations where it will become useful is where the compiler can't recognize the situation as one that it can apply vector operations to. Typically, that's anywhere where you start using a conditional. So if you've got an if where you do a branch based on what you're trying to process, then that's where the compiler starts losing the ability to apply vector operations to that. There's some interesting write-ups on this. If you look at various blog posts that people have written, they've done sort of analysis on the performance of using the standard JIT compiler versus the vector API. And for simple situations, you'll find that the JIT compiler will perform just as well as the vector API. So it's for those more complex operations that this will be much more valuable. How we'll get to hopefully we'll get to the final version fairly soon. Yeah, hopefully it'll be JDK 23, but it's not in the list yet. No. There's only one in the list for JDK 23.
It's now an incubator. Does it mean it still has to become a preview feature before it can be part of the next release?
No, this is where things get a little bit complicated. So Incubator modules are for library features, and some of the distinctions are really quite subtle, and I don't even actually understand them myself, because my thought was that Incubator modules apply to libraries, so APIs. Preview features apply to language features, but preview features can also apply to APIs if they're part of the core classes which relate to a language feature. So if there's an API that needs to be included as part of that language feature, then that would be part of the preview feature. But there are some more subtle distinctions, and I know that things that I thought would have been an incubator have been made a preview feature, and I thought, not quite sure why that's a preview feature rather than an incubator. JEP 11 and JEP 12, I believe, are the two JEPs that describe preview features and incubator modules specifically. One thing I will say is that this is another benefit of the 6-month release cycle, is that we can do this. We couldn't have done this with 2, 3, 4 years between releases. With only 6 months, we can have preview features and then move them forward and then finally make them part of the spec.
You mentioned briefly Java 23, so September. There's only one JEP yet defined to be there. Who decides this, and when will we know what will be in 23?
It's people high up in the OpenJDK. So you've got Mark Reinhold, who's the chief architect of the OpenJDK. He will obviously have input on that. You've got Brian Gertz, who's the chief architect of the Java language, who will also have input on that. And there are other people involved as well, like John Rose, who covers the JVM side of things. So there's a number of people within the OpenJDK who are the top level people who make those kind of decisions.
I found a nice overview of all the JEPs which are now in 22, that you can also group them by project. So you mentioned already Project Amber, we have Project Loom, we have Project Panama. We'll also include links to each of these projects. So for instance, Project Amber is oriented to productivity. Make Java more developer friendly, readable code, stuff like that. So these projects, they live for a very long time, correctly, because they have JEPs in nearly every release for the last years.
It depends if your project is a large project, like for example, Project Amber, maybe it will never die, it will never end. And some projects are more narrowed, and so that ends when the features are integrated into the JDK. So it really depends.
Yes, because the JEPs, JDK enhancement proposals, are specifically designed to be smaller pieces of work. So it's a sort of like a 3-month kind of, well, ideally 3 month, although 3-month kind of time frame for development of those JEPs. Whereas the projects like Loom and Panama and Valhalla, and Valhalla's one of those ones that's been going on for a long time, are much more overreaching, longer planning kind of thing, multi-year.
Loïc, already early January, you posted a detailed blog post about the new features which are in Java 22. You gave examples for that. We'll also, of course, include a link to that blog post. You've written a similar blog post for all the previous releases. So when do you decide, now I know enough to start with it?
I start working those articles for Java 9 because at this time I was very there was a lot of changes in Java 9, and Java 9 also starts to work with so at the Java 9 release time they start talking about 6 months release. So I wrote this, for example, this first article and never stopped. So I usually build my article in steps. First, I wrote everything about the new JEP inside the release. I had a small section about the existing JEPs that have the existing functionality that have a new JEP for a second preview, second incubator, stuff like that. And then I also use the Java Almanac website to see if there is missing functionality, because not everything is in the JEP. For example, for Java 22, we have a list format that is a new formatter, and there is no JEP for that because it's really a small addition. So I also use a Java version almanac that lists all the new API. Yeah, so the information comes, for the people I follow around the JDK from reading the project page that we already discussed, so JDK 22 project page, using tools like the Java version almanac allows me to fill the gap. But reading the JEP, it's really the main way to know what's in a new version. And when I start writing this article, this soon becomes my article that is the most read on my blog. And a lot of people I know said, okay, your article are really cool. Please keep doing this. So I keep doing it and translate it in English, because at first it was an article only in French, because I'm French, and at that time most of my followers was French, but now my blog has the views from all over the world. So I always try to give a translation in English also.
You mentioned about all the new changes next to the JEPs. I'm working on the release notes for our Azul Zulu 22. I think there are over 3,000 Jira items which are included in this. So indeed, every new release is a lot of changes, improvements, fixes, all handled by the community, I guess, or for a big part by the community.
Yeah, it's certainly the case that Java is not a language that's standing still, or a platform that's standing still.
Yeah, and it's both the language and the runtime. People forget that actually Java is two things. Okay, so Java 22 is here this week. Should I move my production system?
No.
Why not?
What is the main conclusion here? Why should people decide to upgrade or not upgrade to 22?
From my perspective, it depends on what you're doing. Because if you're running systems in production and you want them to be maintained with the highest level of security, highest level of stability, then yes, you can move to JDK 22. There's nothing that would stop you from doing that. And as I say, one of the key things to get across here is that JDK 22, even though it's not a long-term support release, it is still production ready and can be used without any problems. What you need to consider, though, is, are you in a situation where you can move to JDK 22 now, and then in 6 months' time, be ready to move to JDK 23, and then in 6 months' time, move to JDK 24? Because that's what you're going to have to do if you want to maintain the maximum level of security and stability, because JDK 22 will only have updates until the release of JDK 23, and then they stop. Whereas JDK 21 has updates for much longer. So if you're running on JDK 21 at the moment, you can continue using it for several years before you need to worry about updating to a newer version.
So it depends of what you're working on and how you manage your upgrade. For example, in my previous job, I work on a small platform when we upgrade on each Java version because we have reduced set of libraries, because there is also always the issue with the libraries you use, because some may not support Java 22, or some may support it, but not very fully tested. So on my previous job, yes, we moved to each Java version, and also because I was very enthusiastic about Java and test all versions. But on my current job, we are still running Java 17 for now. I know that we have planned to switch to Java 21, but what is sometimes hard is really all the ecosystem that needs to be that needs to work with the new version. Because for Orchestra is a data orchestrator, so we have plugins. We have 400 plugins, so we have hundreds of libraries, and there is sometimes one functionality in one library that's not fully works. For example, when we migrate to Java 17, we had to add to the command line some add opens directives to be able to use some libraries that uses reflection in a not anymore compatible way. So yeah, for Java. For example, for Java 21, there is change in the security manager. So we will again need to add some flags in the command line, and it's not always easy. It's not always possible to handle the new changes. So for complex project, it's better to stick to LTS version, and especially for us, because we offer a solution that our users are running. They will maintain the Java version machine that runs Crestra.
Mm-hmm. But if you really want a new feature, which is there in Java 22, 23, then you for sure can go to that version and run it in production. That's a bit the idea.
Yeah, yes, as Simon said, there is no fundamental differences between Java 21 and Java 22 in terms of quality, in terms of what's integrated in it. When on the mailing list they discuss about integrating a new JEP, they don't say, no, we will not integrate it because it's an LTS, and so we will switch it to the next version. It's not like that. It's just that they flag as long-term support one release in force. Mm-hmm. That's all.
I think we have handled most. We cannot handle all the JEPs. Is it something you still want to add?
Actually, I'll just briefly mention, because I did mention it as a sort of forward reference earlier on, which is the implicitly declared classes and instance main methods. And this is, again, the sort of second iteration of something that was introduced in JDK 21. And this comes back to that idea of reducing the amount of ceremony that's involved in getting started with a Java application. So in addition to this idea that you can take a source code file and then run it without having to compile it explicitly, they've tried to reduce the amount of boilerplate code that you need to get to that, hello world application that just prints out hello world. And this reduces the requirement to define an explicit class, and then you can have a main method, which is simplified as well. It's one of those things, and I think I may have mentioned this in the last podcast we did when this feature was introduced, in that I think it's a nice idea in principle, but I really don't see that it has huge benefit, because if you're going to learn Java, you're going to have to learn all the features of it. So once you move beyond hello world, you're going to have to understand about object-oriented programming. You're going to have to understand about the structure of classes, methods, instance fields, and so on. So making it simpler to get to the point where you can write hello world application is good, but you're then going to still have to learn all those things to get past that and then start writing a real application. So it's one of those things that, yes, helpful, but I don't know of how much value it really is. I'll probably get criticized for that.
We had this discussion last time, indeed. I'm a big fan because I want to have as much people into Java as possible, and then on the most easy way. But indeed, you have to get beyond that step of hello world. And then,
because I can see that, like, if you look at what you have to do to do the simplest possible application, that might dissuade people from getting started with Java. So if you make that simpler, you're saying, yes, more people can write a hello world application. But the moment they want to do anything beyond that, they're still going to have the same step up that they would have had if they did the first program that way. Just my opinion.
But it's just one of the many new things that's there. So we can keep discussing it. But
we'll discuss it next time as well.
I love it. You're not that big of a lover for it.
Yes, one of the features that are in this release and that are really nice also is structured concurrency. And I really love this new features. I hope it will be soon finalized, because there was this wonderful new thread, thread implementation that are virtual threads that are in finalized. I don't remember when. I think it's Java 19. But in fact, working with threads directly, it's not very convenient. And structured concurrency, it's really a way to nicely work with multiple threads and saying, okay, I will start task in different threads, then I wait that all threads and then I can wait on multiple conditions, like saying, I wait where I wait until there is an exception, or I wait until all ends. So this is really a nice addition to the Java language. And there is a second preview.
Yes, because this is one of those things where writing reliable concurrent code is difficult. There's just no way around it. And it's great to see that we have seen over the lifetime of Java numerous different introductions of various techniques to make life simpler. Because if you go right back to the very beginning of Java, we had threads built into the language, which was different to other languages like C and C++. You need a library to do that in the past, and it was a core part of the language. But you really had to work hard with the thread class, because you really only had wait, interrupt, sleep, and notify as a way of coordinating your threads, and locks, of course. But then we obviously had the JSR 166, which was the concurrency utilities. Then we had the fork join framework. Lambdas and streams also introduced a way of doing things in a little bit better way, because you could do a parallel stream without having to worry about any of the underlying code. And then we've got, as Loïc said, about the introduction of virtual threads is another thing that makes life a lot easier for scalability of applications. And structured concurrency is also very useful because of this ability to sort of manage a number of different things and have them grouped together in the same way that we do somewhat with the try with resources. So it's a similar kind of approach to that. So it's all good stuff.
So a lot in this Java 22 that we can experiment with, that we can use, that we can build applications if we want and run them in production. We can already start looking forward to September for the next one. We'll see what's included in there. Thank you very much for joining this podcast, Simon and Loïc. Thank you also very much to all the listeners of this episode. Keep an eye on Foojay for future articles and podcasts about development and everything related to Java world. Thanks a lot.
Give me a Foo, give me a J, give me the friends of OpenJDK.